the war of open versus closed, I think open has basically won, which is just a simple acknowledgement that all of these models are converging much faster. If you want your model to be used, need to be publicly available and explained and understood. Look, to be blunt, like of all the models that I've seen, I think DeepSeek is really wonderful. I think OpenAI is pretty good. I think Llama has tremendous potential, but I think the Gemini models are the best. The marginal cost of energy and the marginal cost of compute would go to zero.
Chamath, I'm super excited for this conversation just because I think you have a bunch of incredibly hot takes, but also like you're close to the action that's happening across a bunch of things. I'd like to get your reaction to this to start off, which is I feel like there's this weird cycle going on in AI where what the sort of conventional narrative is like ends up flip-flopping in some like reasonably short amount of timeline. I think the two most pertinent ones that have been top of mind for me around this is, if you go back to 2 years ago, the entire narrative was all these companies building on AI are just wrappers. There's no value being created. And I feel like in the last like 30 days, the narrative has like entirely flipped to like all the values in the application layer, et cetera, et cetera. The second one is like 60 days ago, the narrative was like models are hitting the wall. There's no more, innovation happening. And then all of a sudden it's like reasoning models are the new scaling law. Like everything is up for grabs, progress is going to continue indefinitely. I'm curious to just like your meta reaction to those two examples and other ones.
I think it's actually quite emblematic of most nascent markets when they're emerging. So there's only ever three constituents in any market. So constituent number one is what I would say are people that have essentially a huge sunk cost. And so as a result, they have to have a very specific orthodoxy that they believe, because the scale of their decisions are measured in billions or tens of billions or maybe even hundreds of billions of dollars. So there's very little room for them to re-underwrite meaningful changes. So that's cohort one. And then cohort two are the people that in our economy are always trying to raise money. And then cohort three are the people that actually have a firm sense of what they're doing, independent of what's popular. And I think what happens is that the pendulum swings back and forth between these three different cohorts. And in any given moment, one of them gets a little bit more attention than the other because they have a better hot take in that moment. But I think that this whole AI thing right now is largely going through a sorting function, which all markets go through, of which people in each of those cohorts are kind of like reliable and consistent, and which are talking their own book, which doesn't mean that they're wrong, but it just means that they're only right in moments. And then who are the ones that are really prescient and see the future? And then everybody else who's just kind of a goon and ding dong. So we're in that phase of the market of taking those three cohorts and then separating into those four archetypes. That's I think what's happened, and it's happened in every market before it. So it's pretty similar in that sense.
And what's your like very tactically, like what's your advice for people who are sitting in the shoes of like, I get the persona that I care a lot about is like the founder who is trying to build something and like they're hearing all this crazy signal. Like, do you have a sense of like, yeah, what are you doing to get information from the right people and like, not listen to all the craziness that's being talked about?
I don't think that there's anything you can do other than read the actual papers and find a community of people that are speaking about the facts. I mean, look, most founders are going to fail, right? 95% of them. Is it that they're not smart? No, they're all smart. Is it that they're not courageous? No, they're all courageous to start. The problem is they have poor judgment. And the founders that fail in a critical moment fell for something that just turned out to not be true, right? There's a different way of framing this, which is, Josh Waitzkin calls it the most important question. How can you distill a moment to the most important question. And the founders that build enormous companies tend to have extremely good judgment in those narrow moments, right? Where you can get to the most important question and then answer it with high fidelity. So the thing with founders is that most of them, if they are not focused on their own emotional management, are just going to waffle and flip flop and, make a really bad decision. But by the way, I think that that's healthy, and that's the Darwinism of our industry, and that's how it should be in many ways. Um, so I think that the founder needs to go back to first principles, so often used now, but what does it even mean, I guess? Um, like, 2 weekends ago, the founders that are one step closer to knowing what the most important question was the one that was actually uh, downloaded DeepSeek, implemented it, played with it, read the paper, then read about GRPO, then read about PTX, then actually asked their team why should we be avoiding CUDA? Why did these guys find these improvements by avoiding CUDA? Should we actually why are we only so reliant on um, PPO? Those are some of the right questions. Still doesn't mean you're going to be successful. But then there's an entire cohort of founders who didn't even know to ask those questions. Those folks they could still be successful, but the propensity is that way of making decisions will cause them just, unnecessary waste and time and, disorientation. Because in 2 weeks, there'll be another DeepSeek moment. And 2 weeks from that, there'll be another. And then there'll be another. And so if you're not building the reps to try to make good decisions in a repeatable way, you're just going to fail.
Yeah, to pull on this DeepSeek thread really quick, actually, is your take that it's all of the craziness that people are making it out to be, or like, and actually, like, maybe practically for like you all at 8090, like, did you wake up in the last 2 weeks and like, we are the platform is different? I know you've talked in the past about like you have infrastructure to be able to like swap out models and all that type of stuff, but like did you like actually transition workloads over to these new models, or has it just been like, hey, this is a useful information for us to keep in mind as we keep building?
The honest answer is it's something in between, because did we play with them? Yes. Um, did we realize that we weren't moving fast enough? Also, yes. When, like, inside of 8090, there are these three layers of our cake. One layer is just the application experience that we work with on behalf of our customers and enterprises. One layer is all of the systematic automation that makes it go super fast, which is what we call our software factory. But then the third layer is this wedge in between that we call high performance compute. My initial instantiation of that high performance compute team was just wrong. The people were excellent, but what they were able to do, which was extremely low level hardware oriented manipulation, was a little bit miscast in our organization, because we were largely a software organization and we didn't have the justification to manipulate the bare metal. But then when I saw the approach that DeepSeek took to get some of these performance optimizations, I realized, actually, hold on a second, there was a different way of writing to the bare metal that we hadn't seen. And what we did in that Monday morning, our first 3 hours of Monday are all just very intense, detailed product review. It's kind of like the most important stuff we save for the first meeting of the week, before everybody just gets tired and frustrated, and the first 3 hours of Monday were just like pinpointing all of the places in which, to be honest, we had either gotten a little lazy, or we had made assumptions that were just invalidated, or we had tried an approach that was just wrong. And then to rebuild a product plan for this next week that starts to embrace some of these changes. So, in a couple of weeks, I will tell you that we hopefully will have embraced everything. But my big takeaway from DeepSeek is just that the resource constraints of a small, nimble team should never be underestimated. And that the surplus of resources for large teams is a horrible distraction. That's a rule that I have known for being in Silicon Valley for a quarter century, and I always ignore it. And it's always staring me in the face. And it's a wonderful reminder of that thing. It's small, extremely resource constrained teams that land big things. And when the resources get quasi infinite, you just make very orthodoxical decisions that never that tends to not yield in great outcomes.
Chamath, I'm curious because it feels like, given your historic stance on capital moats and AI, like, do you believe that these open source models can truly challenge proprietary models themselves? Like, where's your stance on that?
I think in the war of open versus closed, I think open has basically won. And I think that you see that capitulation now because even, as of this past week, I think that OpenAI is now considering some form of open sourcing what they're doing, which is just a simple acknowledgement that all of these models are converging much faster, that the innovations, if you want your model to be used, need to be publicly available and explained and understood so that then the incremental changes that one would want to make a lot of sense. I think that there's just too much vendor risk for using closed source. It requires too much tooling. It's way too expensive and it's unpredictable. So meaning, if you have some deterministic workflow inside of a company, and all of a sudden you're going to replace that with quote unquote AI, you're going to introduce some non-zero error rate at some point in that process, right? Some model is going to barf at some point and do something that's unpredictable. So how do you want to manage that risk? Do you want to have it be a black box where all of a sudden your engineers are like trying to use some tooling, can't figure it out, so then they're calling their customer service rep that's escalating and then 4 days later something is fixed? Well, maybe that works if you're an inconsequential consumer application, but if that kicks off a HIPAA violation, or all of a sudden you have a SOC 2 violation, which then all of a sudden triggers a banking violation, there's many markets, many regulated industries in which that idea doesn't work. So open source is just a faster path to putting a bounding box on risk. So I think that's one big reason open source wins. The second is just pure functional cost, because when you trade them off, you can just see that the open source models in its implementation, in part because of its ingenuity, are turning out to just be much, much, much cheaper. Ultimately, I think that the right approach is to be, pretty promiscuous, which is to say that there's an intermediate layer that needs to be able to understand what model is good at what, and given a price trade-off or a performance trade-off, be able to understand what to use at what time. And I think when this AI market, quote unquote, or this ecosystem or economy becomes more sophisticated, that's what will happen. You'll have if you think about in routing, right? Why do we have routing tables? Well, you have routing tables because for OSPF or some protocol to work very efficiently, you're essentially pre-calcing basically the shortest path routes so that you have optimal delivery of packets. And that pre-calculation makes a lot of sense. I think that there's an analogy. It's not perfect, but I think there's an analogy here, which is that models are effectively the same thing, right? So if you're a hospital and you want to use a model for breast cancer prediction, I mean, you want to run 5 of these things, and you want to maybe do some mixture of experts. Maybe you want to do some chain of thought. Maybe you want to do both. Maybe you want to do some reinforcement learning. Maybe you want to do some super fine tunes. Swap them around, right? all of those things should be possible because maybe for them, cost is less important, but the quality is that there can be no errors, right? We can never have a false positive in breast cancer detection or something. Today, that's not really possible, right? You're very linear, right? You pick one model and you go to the end. That's just not how real world works. If the answer is the patient should never be told she has breast cancer if she doesn't. If the answer should never be told, not 99.9, which doesn't work if you're doing 5 million breast cancer scans a year, right? That 0.9 error rate is ginormous. You have to have more flexibility. So I think the pendulum will swing to open, and I think the infrastructure that's really not there in production today but needs to be there are these shims that allow you to eval and trade off and effectively like these league tables for models for different workloads against different price and performance trade-offs.
Chamath, to play devil's advocate on this, like maybe this is tough because I think like I agree with you in some sense about like the innovation that's happening in open models, but is this not also like a bet against like all of the innovation that comes out of these foundation labs? Like, do you not think that there'll be, the GPT-5 level of progress, or is your take that like there will be that GPT-5 level of progress, but like the progress that we're going to get is going to come out of like open source and not out of, one of insert whatever lab is your favorite?
Well, maybe I'll answer a different way, which is where will all of the investment that's being made by closed models pay off? Right? I mean, that's kind of, I think, what you're asking. And I think that there is a very large economy for that. I think that you are going to find that narrowly tailored use cases may not need this generalized approach that I'm talking about. And that the incremental improvements from going across models creates too much either latency or complexity or cost overhead that isn't justified by the quality. And I do think that there are models, and look, to be blunt, like of all the models that I've seen, I think DeepSeek is really wonderful. I think OpenAI is pretty good. I think Llama has tremendous potential, but I think the Gemini models are the best. I'm not just saying that, but I do think that they are. The thing that now, Google needs to do is just to create that ecosystem where there are very narrow use cases that get to scale and that are in production. I mean, I think the biggest problem with our AI economy, to be quite honest with you guys, is that we have a bunch of fake toy apps, and I don't really see anything of any scale or importance in production. And so the longer that is true, the more the open source world wins because we're still in the toy phase. The faster that the closed models actually get to a handful of use cases that are legitimate and reliable by, folks that are not just using experimental toy budgets, but are actually building things that are used, that are felt by consumers or patients or customers, that's where the lock into the closed source models comes in. And that's what will justify all the investment and all the innovations. But otherwise, I think generally many of these innovations are going to converge. There's going to be a time lag, 6 months, 9 months, a year, but that's not going to mean much in 10 or 15 years, I think.
Off that too, I mean, and kind of going back to the reasoning models and agentic models as well, like obviously there's a lot in production, to your point, maybe a lot of fluff. What do you think will be needed to require and unlock the full potential of those models? Is there like a benchmark as soon as...
No,
yeah,
it's a great question. Your question is the $1 million question. So like, if you think about what are we really good at? And this may be some very heterodoxical statements that piss people off, but this is what I believe. Like, what are like Replit and Cursor and Copilot, what are they really good at? I think they're good at supercharging an individual engineer. And at the limit, it'll make a 1x engineer, a 10x, maybe it'll make them a 50x engineer. I don't know. But it's still only one person. And so then you ask the question, well, how do the three of us, if we're working together, actually use these tools together? And it's kind of maybe figured out, but not really. And if you actually apply the problem to a very, very complicated repo for a big, complicated product at a real company that has real world consequences, like, look, if something gets screwed up in Google and you have to, revert some push because it just like was totally borked, there's a dollar cost, and somebody will show up and say, hey, this is how much that stupidity just cost you. Obviously, that's not true for a startup. So today we have these like really good tools that can empower an individual person. But the things that that individual person can create is basically pretty nonsensical. It's not a real app. Like if you could make Facebook blue, okay, now you're cooking with something, right? If you could make Google search, if you could rebuild GFS and Bigtable just with a prompt, okay, great, we've solved it all. But the honest truth is that's not where we are. We all know that. So I think that what needs to happen is the extremely, and I'm not going to say this in a nice way, this is tedious, unglamorous work to go from 99% to 99.9%. That's going to take 2 years of just grind it out, unglamorous, like, you're just like, it's not fun work. But what is that work? It's about fine tuning and training these models to be useful, and then really connecting to the connective tissue inside of an actual organization so that this code is reliable. And that this code actually works as advertised. And I think that people that think that statement is glib, and they don't understand the scope of the problem because they probably never talked to a real customer. And we talk to these folks every day. We have so many regulated customers in energy, healthcare, financial services, manufacturing, and on, life sciences. And the biggest thing that I took a step back at 80/90, I was like, oh man, this is a way harder problem than I thought. Not having some guy use Cursor to gin up some code, that's easy. But all of a sudden now going through like 30 pages of security protocols and this and that and everything else, and then being able to attest that this deterministic system that we've replaced with a fundamentally probabilistic system at some points along the way is going to behave as advertised at the level of accuracy that they're used to. Man, that's a hard problem. And again, it is not a glamorous problem. It's not fun. It's not sexy. It's not what you go home and tell people about. But at the end of the day, if there's millions of patients on the other side or millions of banking customers, if you can't make it work for them, AI is a toy economy.
Do you think you get how much of that do you think you get for free? Like how much do you think like, the large model providers, open source model providers are just going to like get you the last the last percentage of reliability versus like how much of that work are you trying to do yourself?
You have to, I think like that's where they can't go. So my point is the models will get you to 99, maybe 98, 99, 99.1. But when you go inside of a large regulated organization and try to convince them to do something, the amount of just like what I would call cartilage, like not bone and muscle, but all this stuff that's required for an organization to run. Now, maybe what happens is we just rip apart all the rules and regulations and none of it exists anymore. And there's no liability from these companies for violating any of these things. That would change the posture where you can just ship code quickly, move fast, and break things. But the real world economy, right? The 100 trillion a year of global GDP is made up largely of companies doing company things. And those are all overseen and regulated in non-obvious and sometimes very Byzantine, confusing ways. And if you're going to use AI to sort of like streamline this entire world, that's the body of work, that's the hardest work. And it just requires a lot of patience and blocking and tackling. That's part of what we're trying to do. I mean, could I have gone and built consumer apps? Absolutely. I mean, I've done it my whole career. I just don't think that's the really big prize in AI if you're trying to figure out how the economy will work in the future, right? You got to step into these millions of companies that exist and answer the question for them, how will I do work in the future? And part of that is not some sexy demo, which you can do. It's the very gnarly part that explains to an entire group of people how they may or may not lose their job. And then to absorb all of the change management, and then to understand all the rules and complexity, and then to do that in an automated way that isn't people dependent, so that you're not building this kind of software on human scale, but on AI scale, at least the time scale. It's just really hard. So I think the models are really excellent. That's a very long way. Sorry, Nolan, I could have made that shorter. The models are really good, but the people who win, they'll be the end boss of grinding. That's what it is. This phase of like really building a successful company is just going to be grindy, ticky-tacky. But by the way, I love that. That's the organization I built at Facebook. You know, I took a bunch of really smarty pants whiz kids and I made them grind.
Correct me if I'm wrong here. This is just a clarifying question. So kind of the argument is I don't necessarily need a model to quickly spin up an answer and give it to me. What I want my model to understand is the steps and the workflow that goes into actually producing that output and trying to retain it more to humans as far as your everyday work. I'm a human. I work in this job. Here's kind of what I do to get the output. Like, is that what your kind of thought process is as far as training that next wave of, all right, we don't need to focus on necessarily the output, but more so the workflow that goes into creating that?
If you go into a company and try to observe a process, you're probably going to find multiple ways of doing it. And so if you're going to replace that or make that more efficient, one of the most important things you need to do is to understand the requirements of that system, so that whatever output, let's just say that there's some magical software factory that can take requirements and spit out working production quality enterprise code. Compliant, secure, all of that stuff. How will you know it did what it did? And maybe there's like some simple answer, but when you look inside of like these workflows, what you see is years and years of humans manipulating badly designed software, so that if the CEO at the top thinks like something is being done by, moving from A to B, it's not what actually happens underneath. Like, you guys probably know this. Like, I'm sure there's many of your peers at Google who do their job in ways that the Google execs who think they're, it would be a huge gap between how they actually do it, some crappy tool that they have to live with. But that's the functioning of the world economy. Surprise. That's how it works. It's not Instagram. You're not just like swiping up, it's not reels and all of a sudden trillions of dollars just appear in the economy. It's horrible, bad software sold by what I call this software industrial complex, where they did a very good job. They're very effective salespeople. They're very effective at feature design, but there's been so much sprawl and so many workarounds that have built up. And so what are you supposed to do? Because now, it's not just within a company, it's across companies, right? It's how company A invoices company B across the oceans. So my point is that, like, for AI to reimagine economic prosperity, once you throw that stupid buzzword statement out and you get into the details are, how the hell are you supposed to do invoicing for a company that has 8,000 employees and there's 50 people that literally are doing it 50 ways, and you can't miss a payment or not receive revenue, because you have a 99.99% error rate now because you replace some deterministic code with some model. They're not going to care at that point whether it's open source or closed source. They're going to think, what the hell have you done? Right? Or you do it in a way which all of a sudden triggers a HIPAA violation, and now you get an audit request from CMS, and that says, hey, we're pausing all payments until we figure out what the hell just happened. What are you supposed to say? Oh, but we use open source? Or, we're really up to date in our token payments? What? Nobody cares. So that's where we are, I think, to like really translate this into the real world. Now, it can be done But this is what I mean by this is like a 10-year journey, and you got to start slowly, and you just got to bite, how do you eat the elephant? Just like one small bite at a time kind of thing.
To me, this feels like you're pitching why the value creation is potentially going to be done by startups. Like, is it not like, all of the cartilage example perhaps is like all of this institutional sort of positioning weirdness that has accrued over time, and like there's no mechanism in large companies to like remove all that stuff. And like the beautiful thing about startups is you are ground zero. You take the raw regulations, you take the raw, whatever it is, operating manual, and you get to start from scratch. And it feels like, maybe I'm too optimistic, it feels like AI has a chance of like really accelerating people who are trying to do that. And I feel like this world of, I'm curious, what's your take on that?
I think you're right in some places, and I'm a little bit confused in others. Like if you go and if you're a startup, obviously, like if your business works, I think what a startup should be doing is you should be using AI to accelerate your ability to have your own custom, what I call like a business operating system. And the analogy I would give for people that are interested is what Tesla did with Warp Drive, or now what's called Warp, right? So what did Elon do? He hired a really talented CIO, and he basically told him, I want an end-to-end system from raw material to the car being sold, and even afterwards, how the car is maintained and serviced. And what that team was able to do about a decade ago was build that end-to-end system that's extremely custom and specific to Tesla. And what that allows them to do is just be very efficient. So to your point, if a startup that enters a business and is successful, my advice to them is build yourself that operating system. Now, that requires some level of investment and commitment as well, but these AI tools will at least shrink the OpEx that you will have to spend theoretically to get there. But again, it just brings up this case of, well, what is everybody else supposed to do? And there, I think that startups trying to improve things for enterprises are stuck in a bit of a dilemma, which is that the traditional venture model, right? Like if you graduate from Y Combinator, or if you raise a Series A from a well-heeled investor, what they want to hear is a very narrow pitch, right? Here's this one thing. I'm going to do this one thing really well. That's why you should give me 10 million bucks, and then we'll go from there. The problem with this idea inside of an enterprise is that all you're doing is you're replacing a million of these little things with a different of these little things. And I don't think that that's going to work. And the best example of that is Palantir. Because what Palantir says is, screw all of this software industrial complex. This is all just worthless. It's dumb. And I'm just going to create a substrate, and you can decide with us over time how you want to build on top of this and hang, because at the end of the day, like, what are we talking about? We're talking about a bunch of 3-tier apps, right? We're talking a bunch of UI, a bunch of APIs, right? And a CRUD database. This is not super complicated. So I think that de novo startups that find a business model, I would encourage them to build their version of Tesla's Warp. I think the startup trying to build like an AI-enabled replacement for some enterprise tool, I think it's a good thing to do. The problem is you're going to go up against a more sophisticated selling motion of companies that say, look, let's just start with an entire substrate, and we'll hang different apps off of that, many of which we will build for you, others which we can just enable via a platform. And that sale will be done at the CEO or CFO level by somebody that's very credible. And so now the question is, can this startup, who's roughly run by an anonymous person, compete against Alex Karp when they're selling the same Fortune 500 company? And I just think that that's a hard thing to assume that can happen well. So, some will, and some of these people will become really exceptional, but I just think that that's unlikely.
Yeah. Can we shift gears slightly to the AI build out and like the hardware, massive amount of capex. I feel like that was a huge topic of conversation last year. It kind of felt like late 2024, we were spending a little bit of less time talking about it. Everyone was sort of making their bet. And then I feel like in the last 30 days, it's now reopened up on both dimensions, actually, this like question of the massive build out and like how much more there still needs to be done there. Pushing on this, you had I don't know if it was a talk or what it was, but I've this thread, and Nolan and I have actually talked about this a long time ago, around just like the cost of energy. And I think you had some bold takes like 2-3 years ago about like basically the cost of energy going to zero, potentially the allocation
and the cost
energy,
of compute.
and the allocation of like resources in the Middle East because of how like much energy abundance they had and how manufacturing would sort of move to some of these places. I'm curious now, like, for you to reflect on that and like how do you think this is all playing out at that broad sense, but also like specifically in the AI ecosystem?
Yeah, in the broad sense, I think that was roughly directionally accurate. I think that, so my statement a couple of years ago was I was pretty sure that the marginal cost of energy and the marginal cost of compute would go to zero. And I say marginal cost because my focus at the time was, look, taping out a chip is still somewhat expensive. Depending on the process technology, there's still money, right? But meaning like maybe like if you want to think about it like the cost of an EC2 instance, like, is that just only going to get cheaper? Yes. Is the cost of using a TPU going to get cheaper? Yes. And specifically where I was focused was in the division between training and inference. And again, just to put my bias on the table, I was very invested financially and emotionally because I had helped start this company called Grok with a former coworker of yours, Jonathan Ross, in a world of massive inference, right? So I'm very biased in that point of view, but intellectually, I kind of came to this conclusion that when I didn't know when training became a roughly solved problem, so we were only working on small amounts of improvements, that most of the focus and energy would go towards inference, and that there would be so much of it, like 100x, that it would effectively be zero. And it would effectively have to be zero because, again, the difference between deterministic and probabilistic code is that at some point, probabilistically, you're going to have some errors, so you're going to have a bunch of runs sometimes. And so you're going to need it to be super cheap so that you can afford to make mistakes, right? So that's that cost quality trade-off. The energy one was largely because when you looked at the curves of how dependent the United States was on foreign energy, it was a curve that was basically going to zero. And when you looked at how much energy we were exporting, it was the exact opposite. It was just sort of like inflecting up. And that was when we had very nominal amounts of specifically solar penetration in the United States. And this was before we had any form of, 2 years ago, we didn't know that Donald Trump was going to win. So we couldn't forecast the boon that will probably come at some point when he or they make it easier for, small modular reactors and, or even traditional nuclear to get spun back up. But he's already spoken about, making it much easier to, extract and refine nat gas and oil domestically. So that was one data point. And the other data point was how quickly the Middle East was monetizing their oil, which is to say it's in the ground. They were ripping it up and they were selling it and putting money in the bank, right? That's the process of monetization. And when you put these two things together, you could see that there was just this massive surplus of energy coming. And with all markets, sort of like the typical supply-demand imbalance would dictate that with so much supply, the marginal cost of an electron will effectively be zero. And I still very much believe it. And I think the only problem is neither of those two things have played out. I feel even more firmly in it. Now, why hasn't it played out? One is regulatory capture in America. And the second is what we spoke about in that first section of our discussion, which is that there really aren't any real production apps at scale. So there's no infinite need of inference compute other than ChatGPT, other than Gemini, maybe a few use cases for like ads targeting at Meta. But we need 100x more traffic, which means we need 100x more winners. And we're not there yet. We're at the early phases where a few folks have a ton of usage and nobody else has any usage. That's roughly the truth. But I think in the next few years, again, back to the first part of our conversation, more open source alternatives, everything becoming cheaper, everything converging on quality, more shots on goal, right? A few of them will get through. A few of them will become winners. That'll grow the pie. It'll drive more inference. Meanwhile, the regulatory wheels will continue to churn, and the surplus that we have today. So we're almost at the point now where we are absolutely non-reliant on external energy imports. We're probably going to cross that curve at some point in 2025, which is an enormously important geopolitical thing. Tremendous for peace. There's many positives there. That'll tip. And then when the land leases on federal lands get accelerated and fast permitted, and this energy starts to come online probably 2 years later, 2.5 years later, it's just going to start a tidal wave that you won't really be able to stop. And then if you compound that with SMR. So all of these things are converging. By the end of this decade, I think that we're going to be awash in inference that's effectively zero and energy. So that's sort of where my head is at. In terms of specifically AI, we're actually, so if you think of that's where the puck is going, there's one very narrow problem in AI that is not solved yet very well, which is around cooling. And specifically, the process architecture that we use creates some fundamental constraints that generate enormous amounts of heat. So especially if you're using EUV, you're at 2 nanometer, the reality is this stuff runs super hot. And so all this liquid cooling stuff is very heavy, it's expensive, and it's pretty gnarly. Like, it's not very good. So there are some movements afoot to really think about cooling using inert substances, using gas, being able to have a heat exchanger that's highly efficient. That will also be a limiter. And and fixing that is critical, because you get into this very negative loop otherwise, which is if you have only like the most advanced hardware that then has the most complex and demanding cooling characteristics, that then only has, a really gnarly solution where if like all of a sudden, like, I don't know, just like a plane accidentally flies into this data center, you have this like crazy noxious stuff like leaking all over Tucson, Arizona. That can't be how, like we deal with this stuff. But even if that kind of an event didn't happen, I think that you have a constraint of energy in cooling these things, so then it dictates where they can be built. And I think you want more flexibility than that. Like, you want to have edge computing everywhere. So you want to have much, much lower power profiles, which you can solve in a manner of ways. But the combination of a simpler process architecture, I don't know if you guys saw, but there was some stuff that said that Hynix just actually found some workarounds to EUV that they think is even more efficient. So you're not going to need these super crazy ASML machines to do these like, crazy extreme ultraviolet, deposition schemes. And then there's some really interesting innovations around cooling. I've been working with actually a guy on this for like the last couple of years. We're sort of at, TRL4, which in that engineering parlance just means that, we're almost basically at working prototypes of this thing, which is completely inert and uses CO2 gas. And part of where I learned that this problem existed was from Grok, because like when they're deploying inference, it's like, man, this is, you see, it's just, you can't expect that energy is going to be everywhere. And then if you want to have small data centers literally dotting every place in the world so that you can have hyper like millisecond fast inference everywhere, you're going to have to solve these practical problems. And so, I think there's some very, very minor things that we need to fix for the AI scaling, but the infinite compute, infinite energy thing is, I think we're like 3 or 4 years away from just complete infinite abundance.
And I'm
I
guessing,
give these
obviously,
very long answers. I apologize for these very long.
No, it's good. And I
answers.
think kind of, hitting on global energy and more so hitting on social capital. And again, I think the thesis is, over the next decade, technology innovation will create multiple $10 trillion markets. And I was looking at some of the different verticals or domains, obviously deep tech, global energy, which we just talked about, creator economy. But one that stood out, and the actual wordage of it stood out, was life sciences. And I think it's quoted as where drug discovery is moving out of the realm of PhDs and chemists into the hands of computer scientists, which again, I think is I totally agree. I think could be alarming for folks who might read that on a piece of paper. They're like, wait, what? But would love to get your reaction to whether it's organizations or companies you're currently talking to, but like, is there a means for trying to, marry the two hand in hand where, a PhD and a computer science degree is kind of the new standard for folks trying to build in that space? Like, just kind of curious to see how that plays out.
So
I think that's great.
I wouldn't exactly say a PhD, but I would agree with you that if you could marry biology plus some form of machine learning, or chemistry plus machine learning, or physics plus machine learning, I think that's like the dark art ninja skill for like the next 5 or 10 years. I'll tell you what we've learned from our life sciences customers. They have a super complicated job. So the first thing about life sciences that I guess I kind of knew, but what I really learned is, man, they have an extremely complicated, what I call capital allocation model. So like if you think purely as an investor, if you think about like generating a certain return, the next thing is you would try to figure out how many bets do I need to make? What are the distribution of those returns to generate that, right? It turns out that life sciences roughly is that way. So it's a highly probabilistic system. There's all these chain probabilities. And so they have a very sophisticated capital allocation model. So life sciences, as a result of that business model construction, is completely open to the kinds of things that AI can do, because it allows them to shrink the error rate in any of these steps, which then as a result cascades through their business process and improves the likelihood of overall success. So I'll give you an example. Let's say that, they say, I'm not scientific enough to get these right, so I'm just going to make these up to make the point. We have a new target for small cell lung cancer. Okay, cool. Well, we want to attack this specific protein. Okay, great. The minute that they maybe start with that, because, lung cancer incidents are high, the reimbursement rates are very good, they want to go after that market for whatever reason. At some point, what they greenlight is like 1,000 different potential proteins. And today, what they'll do is they'll run those 1,000 through a lab. Now, they'll maybe down select to the 100 most likely, but it takes a lot of time and precision to collect that data and then to analyze it. The first place where it may, and you have an error rate, even still, right? Even you take those 1,000 and you down select to 100, then you down select to 10. Now they're going to have to run some sort of initial clinical validation on those 10 to get down to 3. And then maybe they'll do an IND on those 3 and then start the FDA submission process on 1. But then there's a 50% or 60% failure rate anyway. So maybe they'll start 2 and run them in parallel, or maybe they run 3 so they're guaranteed 1 to work. Super complicated. Now you could take AI and just say, let's run that first really important phase in silico. Okay, now all of a sudden you run 1,000, we'll use AlphaFold, or maybe, we'll do a deal with isomorphic and we'll get access to AlphaFold 3. And now we'll do all of that so that now we have a much higher probability of getting, down selecting to the 3 that are really going to work. And then when you look at it through that lens and you follow it, so then in the IND process, there's a whole thing. Then in phase 1, there's a whole thing. And there is just an enormous amount of room if the biologist and chemist knows just a small modicum of machine learning. A simple example would be, across all the number of test sites, how can you distill so that you can get all the submissions to be extremely accurate? There was a retrospective study that was published. I saw it in archive, but it basically said that there was just in collecting the data and assimilating it for submissions, there was like a 0.5 or 0.6% error rate, just mathematical errors. Now, if you think about that over tens of thousands of studies and, how much does the pharma industry spend? 50 billion, 100 billion a year on R&D. You know how many billions of dollars that's flushing down the toilet? Which is like humans, paper, pencil, so that's an example. There are all these clinical submissions. That's an example. If a drug gets approved, there are all kinds of ways in which doctors need to interrogate about the features of the drug and, all of the things where it could go right, it could go wrong. The pharma company has to have an infrastructure to answer those questions. All of these things are things that different forms of models, whether it's protein folding on the way in, to, a simple LLM that can do construction of documents, to a finely tuned one that can answer. So I think that of all the categories I've seen, I think that life sciences is the most obvious because they already deal in probabilities, right? So going back to that they already deal with the stuff. It's like, yes, most, there's an error rate. A bank is much harder. It's like there's, if the error is in their favor, they like it. But my point is there can't be error rates on account opening. But these guys are much more open-minded to the fact that there can be an error rate in protein folding because they live with that every day. And now what you're doing is you're taking a 10% error rate and shrinking it to 1% because you're moving it from humans and wet labs to AlphaFold 3 and a bunch of computers that Demis manages. Like that's a huge win. So yeah, I'm really convinced in life sciences you're going to see a lot of innovation. I think what the first thing you see, to be honest, is you're going to see just a lot of drugs get through the cycle faster. By the way, that's before the FDA says we're going to have like a digital FDA agent that auto reviews these submissions and gives you a 20. Right now you have a 6-month turnaround time. So you have a 6-month shot clock. And depending on which pathway in the FDA, you can get accelerants. Like you can have essentially these coupons that you can use to kind of get priority review, get to the front of the line. All of that could get replaced by you just submit it. And in 24 hours, you'll just get an extremely detailed response from the FDA, a digital reviewer. So I think the cycle in life sciences is one where the errors in probabilistic systems are probably well tolerated enough where you'll see commercial successes fast. Yeah.
Chamath, this has been awesome. I want to be super respectful of your time. The sort of closing questions, you can go rapid fire, you can opine as long as you want to. It's totally up to you. Something that you want to see happen in 2025, something you hope doesn't happen in 2025, and then actually really tactically, like what does your AI productivity stack look like? Like what are you using, the tools and stuff like that you're using every day to sort of, do your job and live your life?
Okay, so what do I want to have happen? So I'll give you maybe a broad macro sentiment and then very tactical. The broad macro sentiment is just, I think we're in a very fragile point in the United States economy where we're either going to establish a new set of rules to govern the next 25 or 50 years. And at the center of those new rules is going to be this idea of transparency. That is an enormous unlock, I think, for business, for real businesses. I think it's actually very bearish for assets, but I think it's really good for businesses. Transparency is great. Like assets, you can see through and notice that the building is not occupied. That building is worth a lot less, right? So transparency is bad for assets. You know, you have some shit coin and all of a sudden you realize that it's literally nothing. That's bad for assets, but it's really good for businesses. And what's incredible is I think that there's things happening in the United States government that could really make that an expectation, not a nice to have. That's my big 2025 wish. In terms of me, very narrowly, at 80, 90, I want to see the first real moments where I can credibly look you in the eye and say, we've solved some of these second decimal and third decimal problems where it's not just cursor. And instead, like something is really inflecting in 80, 90, where now, you know, I can scale to 500 customers next year and really like help them improve what they give to their customers and to the world. Right now, I can't say that. So that's my very narrow wish for myself is, and again, it's just like, it's just hard, man. It's just like grindy, thankless work. What I hope doesn't happen, I hope that the market does not puke when the United States tries to refinance $10 trillion of debt. I think we need the economy to be healthy so that we can get all of these things done. And then my own personal stack, I use a mishmash of many things. So I use OpenAI, I use Gemini, I use DeepSeek for my information gathering and assimilation process. When I'm hacking stuff together, I'm actually systematically moving through all the tools. So I started sort of like last year with the obvious ones like Replit and Cursor. Now I'm in this kind of like long tail of stuff. I mean, I can tell you some of I'll tell you what's on my hit list right now. Hold on. Hold on. I just stopped using Bolt and it's written here. So I am going to try Pair. And then after Pair, I'm moving to IDX. So those are the next two kind of like tools that are on my hit list to try to be quote unquote a more productive engineer. Now I'm a terrible, shitty engineer, so I can't claim to do anything well, but it just allows me to see kind of like the state of play. But at the top of the stack, I kind of use everything. I use Claude as well. I mean, for code generation, I just think like going directly is like really good. And then now that the deep research things are out, I mean, you guys have yours in kind of, which has been very good. And now because of OpenAI, I'd like to play a little bit more with deep research. There's some narrow things like, you know, I'm not a very pro patent person, but there's a handful of things where I was like, oh, maybe we should actually just patent these things. This is for the HVAC company. And so I'm trying to figure out whether we can use it there. And anyways, yeah, so I use a mishmash, but I wouldn't say that I'm particularly like good at it in the sense that I don't feel like it really changed. Like I get more information. Like it's the same magical experience when I started using Google. I feel smarter, but I personally can't say that it makes me 10x better at anything. I don't know if that's wrong to say if that's, I don't feel 10x better at anything.
I think there's an underlying truth and thread of some of this of like how maybe this is our just like human, weirdness of how we see ourselves. The two tools that you should check out if you're done with Bolt, Lovable, people love Lovable.
Lovable, I've went through that. I like it.
Yeah, V0. Did you try V0?
Tried it already. Yeah,
V0 is great. You're on the frontier. I love this.
Yeah.
Chamath, this was a ton of fun. Thank you for spending the time and answering all these questions. We've got a lot more. Hopefully we'll have you back next year. We can follow up on a bunch of this stuff. And thank you again.
Thank you.